Hi. So in this video, we're going to be understanding the essence of trigonometry, right? So this is going to be the essence of trigonometry. And the main idea is to get an intuitive understanding as to how trigonometry works, okay? So we're not going to be focusing on blindly memorizing formulas, but in this case, we're going to understand how this chapter really works. So whenever you think about trigonometry, you should think about the unit circle. Okay, that's how the trigonometry will function. So let's say if this is a two-dimensional plane, I've drawn 0 comma 0 over here, and let's say if on this plane I draw y and x axis, so Cartesian coordinates. Okay, this is y and x. Now the way the unit circle functions is that it's a circle with radius 1, as the name suggests. So you're going to have a circle over here and it's going to have a radius of 1. Okay. Now let's say I draw a point over here. Let's say that if this is point x comma y, and then let's say that I draw a point or I draw a line in between the origin and x comma y. So by definition, if I'm drawing this line, it's sort of like it's like drawing a gradient. Sorry, it's like drawing a radius. So this is a radius r, which we know is 1, okay? And we can also see over here that this line should have a value of theta, or an angle of theta degrees, okay? Now, in this case, what we can do is that we can draw a small triangle over here. So this is going to be our triangle, right? Okay, so let's draw a triangle this way. Okay, now when you have drawn this triangle over here, we can clearly see that it's going to be a right angle triangle. So you can draw 90 degrees over here, and by definition you know that this side over here is y and this side over here is x, right? So you're going to have a certain y-axis and a certain x-axis, right? Okay, so if I take this a bit, if I draw this right angle triangle, then this is what the triangle is going to be. You're going to have a hypotenuse of length 1, which is the radius or a unit circle. This is going to be y, this is going to be x, and this is going to be theta. Okay, so that's what we have seen over here. Now in this case, you can simply say that sine of theta is equal to y by 1. And over here, you can say that cosine of theta is equal to x by 1. So simply SOHCAHTOA. And so you get, in this case, that x is equal to x corresponds to cosine of theta, and then y corresponds to sine of theta. Okay? And so precisely at this point over here, x comma y is just going to correspond to cosine of theta and sine of theta. So this is going to be cosine of theta, and then this is going to be sine of theta. Okay? And so whenever we change this value of theta, you're going to get a different value of x comma y and a different value of cosine of theta and sine of theta. Now, something to note about theta is that if you go in this direction, which is anti-clockwise, then you're going in the direction of positive theta. Okay? And then if you go in this direction, which is clockwise, so this is a clockwise direction, you're going in negative theta. And if you want to know what's clockwise and anti-clockwise, then, this is going to be clockwise. Okay? So the reason this is clockwise is because this is how a clock would function, right? So if you have a clock over here, you've got the minute hand, then the minute hand will move this way. And then if you have got this direction, then this is anti-clockwise. Okay? And that's because the minute hand in a clock goes this way, but we're going the opposite way. Okay? So that's the concept of positive theta and negative theta. So anti-clockwise is positive theta, and then clockwise is negative theta. Okay? So that's the idea over here for the unit circle, right? Good. So now what we can do is that over here, let's say that, I draw another angle, okay? And let's say that this is theta 2. Then therefore, this corresponding x2 comma y2 value, so this is going to be a different value of x2 comma y2, then this will simply correspond to cosine of theta 2 and sine of theta 2, okay? So that's how our x and y values are going to be shifting along the way, okay? Now, the interesting thing to note over here is to sort of, in this case, we can look at the different functions, right? So you have learned about sine function, or you would have seen the sine function, cosine of function, and then you would have also seen that tan of theta is sine of theta by cosine of theta, right? So this would just be relating to SOHCAHTOA. So now in this case, if you look at, you can you can separate this circle into 4 quadrants. So let's say that this is the first quadrant, this is the second quadrant, this is the third quadrant, and then, this is the fourth quadrant, okay? So what you see over here is that in the first quadrant, both x and y are positive, right? Make sense? This is a Cartesian plane, so x and y are positive in the first quadrant. So if x and y are positive, then this means that sine of theta should be positive, because sine of theta corresponds to the y value, as you can see. This means that cosine of theta should be positive, right? And then if sine of theta is positive and cosine of theta is positive, then tan of theta is also positive, okay? And so that's why in the first quadrant, all sine, cosine, and tan are positive, right? Now, in the second quadrant, as you can see, so this is the second quadrant over here, right? So we go to another quadrant. We can see that sine of theta is still positive, right? So in this second quadrant, we see that the value of y is above 0. So sine of theta should be positive, but cosine of theta is negative because x is less than 0 over here, okay? And, if we know that tan of theta is sine of theta by cosine of theta, so if cosine of theta is negative, then tan of theta is also negative, okay? So therefore, in the second quadrant, only sine is positive, only sine, okay? Now you can see where I'm going with this. If I go to the third quadrant over here, so this is the third quadrant, what you see in the third quadrant is that cosine of theta is negative because x is negative. Sine of theta is also negative because y is negative in the third quadrant. And we know that if sine of theta is negative and cosine of theta is negative, then tan of theta should actually be positive. So the reason is because tan of theta in this case would be negative sine of theta divided by negative cosine of theta, and then the negative and negative signs would cancel out, making it positive. All right? And so that's why in the third quadrant, only tan of theta is positive. And then after this, we go finally to the fourth quadrant over here. What you see is that in the fourth quadrant, x is positive, so therefore cosine of theta should be positive. Y is negative, so sine of theta should be negative. And then by default, tan of theta is sine of theta by cosine of theta. So this is negative sine of theta divided by cosine of theta. And because of this negative sign, tan of theta is negative. So therefore, in the fourth quadrant, only cosine is positive, right? So if you would have done trigonometry, your teacher would have sort of, they could have used a few acronyms, right? They could have, I remember the way I was taught, they would say something like ASTC. So it was like all silver teacups, right? That's also a good way to learn, right? I guess, when you're starting off, this is a good way to learn, and then later on you can understand the basics. But I think it's always good to understand the fundamentals before moving on, right? So when you have this all silver teacups thing, you would know that first quadrant, everything is positive. second quadrant sine is positive, third quadrant tan is positive, and then fourth quadrant cosine is positive. Okay, good. So we have seen this idea over here, right? Now after this we can just we can derive a few identities. Okay, so let's derive a few identities over here. So what we'll do is that we'll draw this triangle again. And yeah, these identities are very simple to derive. They just come from the Pythagoras theorem. So we know that this is r is equal to 1. This is 90 degrees. And we know that this is y and this is x. And this is theta. Okay. So this is the unit circle. Okay. And we have learned that y corresponds to sine of theta. So you know that y is equal to sine of theta and x is equal to cosine of theta. Okay. So now you simply apply the Pythagoras theorem. So you know that r square is equal to x square plus y square. So therefore in this case r is just 1. So 1 square is equal to x square plus y square. And 1 is just cosine of theta, so this is cosine square of theta plus sine square of theta is equal to 1. Okay, so that's how we derive this identity over here. Now in this case let's divide both sides by cosine of theta. Okay, so divide both sides by cosine squared of theta, right? So this means that 1 divided by cosine squared of theta is equal to cosine squared theta divided by cosine squared theta plus sine squared theta divided by cosine squared of theta. And so we know that 1 divided by cosine squared theta is equal to secant squared theta, which is 1 plus tan squared theta. Okay, that's how you get this identity. And then over here, the other one is you divide both sides by sine squared theta. So you get that 1 divided by sine squared theta is equal to cosine squared theta divided by sine squared theta plus sine squared theta divided by sine squared theta. And so 1 divided by sine squared theta is cosecant squared theta. Cosine squared theta divided by sine squared theta is cotangent squared theta plus 1. Okay, so in this case you would just see that cosecant of theta is just a fancy name which we have given for 1 by sine of theta, and then secant of theta is another fancy name which we have given for 1 divided by cosine of theta, and then cotangent of theta is just 1 divided by tan of theta. Okay, so they're just reciprocal functions. That's how we would find it, right? Okay, so till now we have understood what the unit circle is, right? And we have seen we have looked at quadrants, and we have done a few derivations. Okay, now in this case the other thing that we can do in this unit circle is we can understand a bit more about how the sine and cosine function works. Okay, so what you have to find over here is that, you know, if this is 0, 0, we have learned once again that if you draw this x and y axis, right? If you draw your set of axes over here, then we would have learned over here that, you know, in this case this is a circle of radius 1, as we have seen, and this is theta, and then this is x comma y, which we have seen corresponds to cosine of theta and sine of theta. So what you can see over here is that since cosine of theta corresponds to the x value, then the maximum value of x is equal to 1, right? Because since it's a unit circle, the value of x can't be greater than 1. So at this point over here, the value of x is 1. So that's the maximum. And then at this point, the value of x is negative 1. So the maximum value is x is equal to 1, the minimum value is x is equal to negative 1, and so that's why cosine of theta oscillates between negative 1 and positive 1. Okay? And then similarly for sine of theta, we have seen that sine of theta corresponds to the x and y value. Sorry, the sine of theta corresponds to the y value. So the maximum value for sine is 1, and the minimum value for sine is negative 1. And so that's why sine of theta corresponds between negative 1 and positive 1. Okay? So that's how we look at sine of theta and cosine of theta. And so these are functions which go between negative 1 and positive 1. Right? Okay? Good. So now after this, what we can do is that we can look at tan of theta. Right? So tan of theta is a very complicated function compared to sine and cosine. And in this case, you can think that tan of theta is actually, it's possible to get tan of theta between positive infinity and negative infinity, right? And that's because tan of theta is sine of theta divided by cosine of theta. So sometimes cosine of theta can be very, very small, whereas sine of theta can be very, very big. And then, when this happens, then it can go to positive infinity. It's sort of like when you divide 10 by a very small number, like 0.00000001, then you approximately get infinity, right? So, for example, over here, let's say when theta is very close to 90 degrees, if this is a value of theta, then you can say that the value of y is almost 1, whereas the value of x at this point is almost 0. So you can sort of see that tan of theta is equal to is equal to sine of theta divided by cosine of theta, and then the corresponding value of y is approximately 1, and the corresponding value of x is almost 0, and then 1 divided by a very small value is almost infinity. Okay? So yeah, right now let's just focus on the sine and cosine functions. Okay? Now we can look to graph the sine and cosine functions. Okay? So we're going to look at how to graph the sine function. So if this is sine of theta, and then over here you get a value of theta, then the sine of theta function is going to go in this direction. Okay? So this is going to be positive 1, and then over here this is going to be negative 1. Okay? And then I'm just going to draw the angles. So in this case, this angle over here is going to be 90 degrees. This is going to be 180 degrees. And then over here, this is going to be 270 degrees. And then this is going to be 360 degrees. Okay? So basically, what you can see is, once again, you have a unit circle. So when theta is 0 degrees, so this is a flat line, right? So at a flat line, we know that theta is 0, okay? So when theta is 0 degrees, the corresponding y value, so if this is the y-axis, the corresponding y value is 0, right? So we can say that sine of 0 is 0, okay? So you start off at 0 over here. Now, in this case, as you go up, right, then it's sort of like this minute hand shifts. Okay, so now the minute hand has shifted, so now we are at 90 degrees. Okay, right? So now that we are at 90 degrees, we can see that the corresponding y value is positive 1. So therefore over here you're going to be at positive 1. Okay, now we shift it again. So now we see another shift, right? So, okay, for some reason that's not moving. Let's do it this way. Okay, let's just leave it this way. Now, in this case, once again, you have another shift. So you make this to be 180 degrees. So we see at 180 degrees, you're back to 0. So the corresponding y value is 0. And so because of that, you get 0 over here. Okay? Then at 270 degrees, the corresponding y value is negative 1. So this is 270. So you get negative 1 over here. Right? And then when you're back to 360 degrees, right? So when you go back all the way back over here, so we have seen over here that the sum of all angles, the total rotation in a circle is 360 degrees. Okay? Now, when we're back to 360 degrees, we see that the corresponding y value is again 0. So at 360, you're back to 0. Okay? Now, the interesting thing to note over here is that sine of theta is a periodic function. Okay? So if you get this thing over here, and let's say that if this is 30 degrees, and then let's say if, I take another revolution and I come back, and let's say that the total angle I've traveled is 360 plus 30 degrees, then you would see that sine of 30 degrees is equal to sine of 390 degrees. Okay? It's because in this case, for 30 degrees, I just go this way, right? And then for 390 degrees, I first make a full turn and then I take another 30 degrees. So this is 390. And at both points, the corresponding cosine of theta and sine of theta value is the same. Right? So that's why sine of theta and cosine of theta are periodic functions. And periodic functions means that they're repeating functions. And the period or the size of one oscillation is given by 2 pi. So they repeat at every 360 or every 2 pi radians. That's when the repetition will take place. So, it's 2 pi or it's 360 degrees. Okay? If you have not learned about radians, then you can use degrees or radians. Okay? So that's the main idea over here. And so that's why what you're going to be seeing is that, the sine of theta function, and then this is the theta function, then the sine of theta function will just be going like this for infinity. And so it's going to keep oscillating between positive 1 and negative 1. Okay? So we have seen how sine of theta and cosine of theta works, and we looked at the intuition for how to graph them. Looking at the unit circle. All right. Okay. Now, after this, we can right. So now let's see how to move on. So we can look at some important angles. That can be something we can do, right? Equations of unit circles. Okay. So yeah, and the other thing to note is, because it's a periodic function, then you can see that sine of theta is actually just equal to sine of theta plus 2 pi, right? So it's like if you go up over here to theta degrees, and then over here, you go up to theta degrees, and then you add 2 pi again. So 2 pi is just 360 degrees, okay? So if you add 2 pi again, then you can see that sine of theta is just sine of theta plus 2 pi. Or in this case, sine of theta is sine of theta plus 360 degrees. Okay? And then this can mean that, this can also mean that sine of theta is equal to sine of theta plus 360 times 2, right? Instead of making only one revolution over here, you can make another revolution. You can make another revolution. You can make 1,000 or 1,000,000 or 1,000,000,000 revolutions, which are multiples of 2 pi, and you end up at the same point. Okay? So that's why we get over here that, sine of theta is equal to sine of theta plus 2k times pi. And in this case, 2 pi is just 360 degrees, and then cosine of theta is cosine of theta plus 2k pi. And in this case, k goes from 0 to infinity. And actually, k can even go from negative infinity to positive infinity, right? So the reason k can be negative is, let's say if over here, this is your function over here, this is 300, and let's say if this is 30 degrees. And so we know that a positive revolution is anti-clockwise, right? But you can make a negative revolution. You can go this way if you want. If you make a negative revolution, you go back to the same point, which is why k can also be negative. Okay? Right? So that's the basic idea of how things would work. Okay? Okay. So that's good. Now we can look at some angles for sine of theta and cosine of theta, and then we can look at a few intuitions for how sine of theta and cosine of theta works. Okay? Okay, so now there are some angles which are required to learn when it comes to sine of theta and cosine of theta, or in the unit circle. So in the unit circle, you've got a radius of 1, right? So we see that over here, this is 0, 0, and this is a radius of 1 on both sides. Now we look at some important examples or some important angles over here. Okay? So there are roughly about some important angles. So the first line is at 0 degrees, right? So when you're at 0 degrees, you will know that on the circle, this is going to be, so on the circle, x is equal to 1 and y is equal to 0, okay? When you get to 90 degrees, you're going to see that x is equal to 0 and y is equal to 1. When you go to 180 degrees, you will see that x is negative 1, y is 0. And then when you go to 270 degrees, you'll see that x is 0 and y is negative 1. So what you can say is that 1, 0 corresponds to cosine of 0 degrees and sine of 0 degrees. Okay? And then 0, 1 corresponds to cosine of 90 degrees and sine of 90 degrees. And then cosine of negative 1, 0 corresponds to cosine of 180 degrees and sine of 180 degrees. And then 0, negative 1 corresponds to cosine of 270 degrees and sine of 270 degrees. Okay? So these are the first 4 examples you should know. And a quick, simply just drawing the unit circle will give you the answer. So, you should know cosine of 90 is 0, sine of 90 is 1, cosine of 180 is negative 1, sine of 180 is 0, and so on. Okay? So just draw the unit circle. If you visualize the unit circle, you will understand trigonometry, right? But if you try to memorize it, it will be confusing. Okay? Now here come the things that you would need to remember, right? And so this one is, when you're at 30 degrees, you should just know that sine of 30 degrees, so this is going to be 1/2 and root 3 by 2. So at 30 degrees, this is going to correspond to, or actually, so this is going to be the other way. So this is going to be root 3 by 2, 1 by 2. And then this is going to correspond to root 3 by 2. And then, this is going to correspond to cosine of 30 and sine of 30. Okay? And then after this, you need to know this angle over here, which is 45 degrees. And so for this, this is just going to be So whenever you get to cosine over here, then this is just going to be 1 by root 2, comma 1 by root 2. So you'll see that in this case, cosine of 45 and sine of 45. Okay? Now, the intuitive thing to see over here is that between 0 and 90, when you go from 0 to 90, the angle that is halfway in between is 45 degrees, right? So it makes sense that, at the average angle at halfway distance, both the x and y values are the same. Okay? So that's sort of why, you can think of why when you go to 45 degrees, both cosine and sine is the same over here. Okay? And then when you go to 60 degrees, so this is going to be 60 degrees. When you go to 60 degrees, then in this case, this is going to be 1 by 2 comma root 3 by 2, which is going to be cosine of 60 and sine of 60, right? And that's about it. Oh, and another thing that you just need to know is you need to know that, if you make one entire revolution, then you come back to the same point. So at this revolution, this 1 comma 0 will also just correspond to cosine of 360 and sine of 360. Okay? So these are the major angles that you need to be knowing. And there's actually a simple way to remember them. So the way I go about it is I just write down the angles. So I know that I've got 0, I need to know 30, I need to know 45, 60, 90, 180, and 360. And then I write down the values of sine and cosine. Okay? So I just remember 1. So I know that sine of 0 is 0, sine of 30 is 1 half, sine of 45 is 1 by root 2, sine of 60 is root 3 by 2, right? Then sine of 90 is 1, sine of 180 is 0, sine of 360 is 0. Okay? Right? And then for cosine, you simply just flip it. So forget about 180 and 360. So forget about these. For cosine, you just flip it. So this is going to be 1. This is going to be root 3 by 2. This is going to be 1 by root 2. This is going to be 1 half, and this is going to be 0. Okay? So as you can see, I'm simply just flipping these values. So they've just been flipped. Okay? So that's why, when you have cosine of theta, you can say, let's say cosine of 60 is 1 half, right? Or, cosine of 30 is root 3 by 2, and so on. Okay? So that's basically how you do it. And then after this, the other angles you get is 180 and 360. So you can't really flip it over here. So you know that sine of 180 is 0 and sine of 360 is 0. And when you look at cosine, then, cosine of 180 is negative 1 and cosine of 360 is going to be 0. So you can apply the flip over here actually, right? And I think the hardest angles to just remember are 30, 45, and 60, right? Whereas the other angles, you can just, use them and see them from the unit circle. All right? And the main idea for trigonometry is you need to always visualize unit circle. Okay? If you visualize the unit circle, so, these values, it's not like I've memorized them. Let's say when it comes to 180, then all I do is that in my head, I think about the unit circle, and then I think about going to 180, and then I find the points of sine of theta and cosine of theta corresponding to 180, right? So I think of a unit circle, and then I think you go to 180 over here, and then I know that at 180 over here, the value of x comma y is negative 1 comma 0. which is why cosine of 180 is -1, and then sine of 180 is 0, which is exactly what we get over here. Okay? So that's the main idea for how we do this. Okay? And then, once we get all this, then for tan of theta, you simply just divide. So this is sine of theta by cosine of theta, and then you do the division over here. Okay? And the important thing to remember is that, sometimes when cosine of theta is 0, then these become undefined. Okay? So, for example, in this case, for example, in this case, cosine of 90 is undefined. Tan of 90 is undefined. Okay? Make sense? And that actually reminds me over here, when you come to 360 degrees, actually cosine of 360 is +1. Okay? Right? So sine of 360 is 0, cosine of 360 is 1, sine of 180 is 0, cosine of 180 is -1. All right? Sine of 90 is 1, cosine of 90 is 0, and so on. Okay? All right? So that's the main idea that you get. So for tan of theta, you simply just take these values and divide them by each other. Okay? And you can use this flipping method if you only want to memorize one set of values, right? And yeah, also tan of 90 is undefined because cosine of 90 is 0, right? And the main way to sort of do these questions is just to practice. The more you practice and do these questions, then the easier it is to recollect what's going on. Okay? Good. So now after this, the other thing that we can do is that we can visualize a sine of negative theta and cosine of negative theta, right? So we can see these things over here. So over here, once again, if I draw the unit circle, so in this case, if I draw the unit circle over here, then what you can see is that when you draw this unit circle, let's say that if this is positive theta, and then this is the exact negative theta, what you're going to be seeing is that the values of x for positive theta and negative theta are always the same, right? So that's why you can say that cosine of theta is equal to cosine of negative theta. Okay? But on the other hand, the y values, as you can see, are inverted. So that's why sine of negative theta is equal to negative sine of theta. Okay? So that's where the inversion happens. And so in this case, you can see that tan of negative theta is equal to sine of negative theta by cosine of negative theta, which is negative sine of theta divided by cosine of negative theta is just cosine of theta. Okay? And so this is negative tan of theta. So just understand sine and cosine very well, and then for tan you can just do the divisions and show it that way. Okay? So that's the main idea over here for how we look at sine of negative theta and cosine of negative theta and so on. Okay? And if you look at the graphing over here, then if you look at the sine and cosine function, then basically the sine function behaves this way. So I'm going to draw, so let's say if this is theta, and then this is the graph of sine of theta, and we know that sine of theta goes from 1 to -1, and let's just draw the angle. So 0, 90, 180, 270, and then 360. So then in this case, the sine of theta function will sort of will move this way. Okay? All right. And then the cosine of theta function. So we know that cosine of 0 is 1. So the cosine of theta function will start over here. We know that cosine of 90 is 0, so it will go this way. We know that cosine of 180 is -1, so it's going to go this way, okay? And then cosine of 270 is 0, and then cosine of 360 is 1, okay? So this function over here is going to be sine of theta, and then this function over here is going to be cosine of theta, okay? So that's the main idea over here. So you can graph this by just seeing that, cosine of 180 is -1. So cosine of 180 is -1. Cosine of 90 is 0. Cosine of 0 is 1. And what you see is that the angular difference between these is 90 degrees. Okay? So it's sort of like, if you take the sine of theta function, right? If you take the sine of theta function and then let's say if you shift it to the left by 90 degrees, so sine of theta plus 90 is just cosine of theta. And then similarly, cosine of theta, so in this case, and then cosine of theta minus 90 is sine of theta. Okay, so I'll explain this over here, how we get to this, right? Okay, so this is like, this is just the trig identity that we're simply just going to apply over here. So we know that sine of 90 plus theta is cosine of theta. And the reason is because, if you have a function which is y is equal to f of x, then if you do f of x plus h, then you're simply just shifting to the left by h units. Okay? So this is just the transformation of a function. Okay? So okay, so the way we can do this, right? So the way we can just do this over here is that, let's say if we have a function, right? If this is a function where, y is equal to x, right? So we know that f of x is equal to x, correct? Then if we draw this function, let's say f of x plus 5, let's say, then this should technically be equal to x plus 5, right? And then this is going to be f of x plus h. Okay, so you have simply just shifted it to the left by h units. So that's what f of x plus h is. And then on the other hand, if f of x is equal to x, then f of x, let's say if you have f of x minus 5, then this should actually just be x minus 5. And in this case, if you make f of x minus 5, then all you're doing is that, this is your function. This is f of x minus 5, and then so you have shifted everything to the right by h units. So when you have a negative, you're going to the right. When you have a positive, you're going to the left. Okay? So if it's negative, you go to the right. If it's a positive, you go to the left. Okay? Right? So, okay. So that's the main idea over here. And so the way you think about it is that when you have sine of theta plus 90, what you're basically doing is that you're going to the left by 90. Sine of theta plus 90 is you're going to the left by 90. Okay? So if I take this sine of theta curve, okay, and then I go to the left by 90, then what you're seeing is, this is my original sine of theta position. So as you can see, I wanted to observe this dot over here. Okay? So at this dot, I am at 180 degrees. Now if I go to the left, then I go from 180 to 90, so I'm going to the left by 90 degrees. Okay? So therefore sine of theta plus 90 is cosine of theta. Alright? And then similarly, what you can see over here is that you can look at this, you can look at this function over here, right? Now on the other hand, if I've got cosine of theta minus 90, so if it's theta minus 90, I'm going to the right by 90. So if I take this cosine of theta function, right? Okay. So actually let's make another line over here. So let's say that this red line is your cosine of theta function, right? Now if I take this cosine of theta function and then I do theta minus 90, so I go to the right. So as you can see, if I take this function to the right by 90 degrees, I overlap with the sine of theta function. Okay? So this is my original one, then I go to the right by 90 degrees. So cosine of theta minus 90, and then I end up at sine of theta. Okay? All right. So that's how we looked at some of these identities, such as sine of negative theta, cosine of negative theta, and then these shifting functions that happen. All right. Okay. Okay. So that's one of the things, right? And then after this, the other thing that we can look at is that we can simply just so now after this, the other things that we can look at is that we can just look at the concept of a reflex angle to finish off this topic, or to finish off this video. And so that's the topic of reflex angles. Okay. So in this case, we know over here that when you have 30 degrees, in this case, when you get cosine of 30 and then sine of 30, so if you get cosine of 30 and then sine of 30, then cosine of 30 should correspond to root 3 by 2, and then sine of 30 should correspond to 1 by 2, right? Okay. So this is cosine of 30 and then sine of 30. Now, what happens is, let's say if someone gives you an angle, right? They give you this angle over here and they call it 150 degrees. And they say, can you tell me what cosine of 150 is and what sine of 150 is without using a calculator, okay? So once again, always visualize the unit circle. So when you get 150 degrees, what you do is that you take the angle between 150 degrees and the x-axis. So reflex angle is always taken with the x-axis, okay? And then I get this reflex angle over here to be 30 degrees, all right? Okay? So remember, take the reflex angle with the x-axis. So what you can see is, hypothetically, when you get to the second quadrant, what you can see is that in this case, cosine of 150 and sine of 150, right, is going to correspond to cosine of 30 and sine of 30, right? But because we are in our second quadrant over here, then cosine of 30 should be negative. So therefore, cosine of 150 and sine of 150 are going to be equal to negative cosine of 30 and positive sine of 30. And the reason is, you can, once again, that's why it's important to visualize the unit circle, is because, if you draw these two lines, you're going to be seeing that when you're at 30 and when you're at 150, the corresponding values of y are exactly the same. And that's why sine of 150 and sine of 30 So this is a reflex angle. So 30 is a reflex angle. So these two values correspond to each other. And then the corresponding x values are also very, very similar. So the magnitude of the x values is the same, but in this case, this is negative, which is why cosine of 150 is negative cosine of 30. Okay? So we'll be doing more examples on reflex angles, but basically reflex angles are always made with the x-axis. And you have to learn about, you have to just know you have to know at in which quadrant sine and cosine are positive or negative. Okay? So let's just look at another example. Okay? So okay, so let's look at this example over here. Let's say someone wants you to find sine of 240 and cosine of 240 degrees, right? And they ask you how would you solve for it. So what you would do once again is you would simply put it on a unit circle. So this is your unit circle over here. This we know is 0, 0, right? And in this case, I'm drawing the x and y axis over here. Okay, so this is y, negative y, x, negative x. And then let's say I draw 240. So this is approximately 240 degrees. Okay. So we know that the first half over here, this is 180. And then in the second half, I add 60 and then I get 240. Okay. Now, when I'm at this point, once again, I find the reflex angle. Okay. It's important for to find the reflex angle. So at the reflex angle over here, what you're going to see is that this is 60 degrees. Okay? So therefore, you can see that cosine of 240 degrees and sine of 240 degrees are going to be related in some way to cosine of 60 degrees and sine of 60 degrees. And always remember the reflex angle is with the x-axis. Okay? Now, in this case, because you're in the third quadrant, then cosine of theta and sine of theta should be negative, which is why cosine of 240 must be negative cosine of 60, and then sine of 240 must be negative sine of 60 because you're in the third quadrant. Okay? So that's how you would solve for this, right? Okay? So now in this case, so that's how you would be looking at reflex angles in the unit circle and seeing how to do it. Now don't memorize that if in whatever quadrant you are, you should make it positive or negative. You just have to visualize the things, right? So in this case, when you're in the third quadrant, you see that x and y are by default negative, which is why cosine of 240 and sine of 240 must be negative by default. Because in the third quadrant, sine of theta and cosine of theta correspond to the x and y values. Okay? Now, in this case, what you can see is that, if this is your angle in the first quadrant, where this is 60, and let's say if this is your angle in the third quadrant, right, this is also 60. So the angle in red, so this red one is going to be the reflex angle that we were seeing before, right? So what you're going to be seeing for both of these points is that the magnitude, which is cosine of 60 and sine of 60, this is going to be negative cosine of 60 and negative sine of 60. So, even though the absolute value, even let's say if you forget about the sine and if you only see the absolute value, then these two would be exactly the same. But, you would show a negative sign over here because once again, x is negative in the third quadrant and y is negative in the third quadrant. Whereas in the first quadrant, this is the first quadrant, x is positive and then y is positive. So you just draw the Cartesian coordinates with a radius of 1 on the unit circle to see how that thing takes place. Okay? Right? And so, yeah, and before moving on, we can simply just list down, in order to just, complete this topic, we can just list down a few things over here, right? So the basic things that we can list down is the compound angle identities. So just proving them tends to be more tricky. You need to draw two triangles for these. So it's just although there are a few intuitive proofs for this as well, but I think for now it's the good idea for this is you can just sort of memorize them. So the sine of a plus b is sine a cosine of b plus or minus cosine of a sine of b. And then cosine of a plus b, a plus or minus b is equal to cosine a cosine of b minus plus sine of a sine of b. So what this basically means is that, if there's a positive sign over here, then the inverted sign means that there should be a negative sign. And then if there's a negative sign over here, then there should be a positive sign. That's why the inversion happens. So, what this means is that in this case, cosine of a minus b is equal to cosine a cosine of b plus sine of a sine of b, and then cosine of a plus b is equal to cosine of a cosine of b minus sine of a sine of b, and then similarly sine of a plus b is equal to sine of a cosine of b minus cosine of a sine of b, and sine of a minus b is equal to sine of a cosine of b minus cosine of a sine of b. Oh, and this should be positive, right? All right. So, yeah. Okay. Okay. All right. So, these are just your double angle formulas. Okay. Right. So, you can, these are also given in the formula booklet, right? If you would see those. Okay. And then the other thing is tan of a plus b. So tan of a plus or minus b is equal to tan of a plus or minus tan of b. And then this is 1 minus plus tan a tan b. Right? So there are some proofs for these formulas. You can see them online. And I think I'll do one of the proofs to show how sine of a plus b works. Okay? All right. So that's the main idea for these double angle formulas. Okay. And basically, when you get, so these are compound angle formulas. So once you get the compound angle formulas, then getting the double angle formula is easy. Okay. So basically, what you can say is that sine of 2 theta is just, sine of theta plus theta. And we have learned that sine of a plus b is simply going to be sine of, sine of a. So this is going to be sine of theta times cosine of theta plus cosine of theta sine of theta. And so this is simply just 2 sine theta cosine of theta. Okay. So that's what sine of 2 theta is. And then similarly, cosine of 2 theta is simply just cosine of theta plus theta. So this is what we are dealing with over here. And so this is going to be cosine of theta minus sine of theta, which is cosine squared theta minus sine squared theta. Okay? So that's the main idea. And then similarly, tan of 2 theta is just tan of theta plus tan of theta. And so we see that, tan of a plus b, so this should be tan of theta plus tan of theta, and then this is 1 minus tan of theta times tan of theta. And so this simplifies to be 2 times tan of theta divided by 1 minus tan squared theta. Okay? So these are just some double angle formulas. So if it's in your syllabus, then you can go through them, and if not, then that's well and good as well. So yeah, so this is how double angle formulas work. So the main thing is to look at the compound angle formulas, and then the compound angle formulas, they do some they sort of do some additions where they have like two triangles, and then they try to like map sine of a plus b on those two triangles, right? But there's a simpler proof to show how sine of a plus b works. So I will go over that if possible. Okay. All right. So yeah. So with this, what we have done is we have had a comprehensive view of how trigonometry works. We have looked at the unit circles. We have seen how the x and y values correspond to cosine of theta and sine of theta. We have looked at the trigonometric identities, the four quadrants, how cosine of theta, sine of theta works. We have looked at how sine of theta and cosine of theta are periodic functions, how they oscillate between -1 and +1. We looked at the graphs of both of these functions. Then we looked at all the special angles you need to know. Then we also showed sine of positive theta, sine of we said how cosine of negative theta is cosine of theta and sine of negative theta is negative sine theta. Then after that we looked at a few transformations. Okay. We explained, and then we did one or two examples over here, looking at reflex angles, so that's important. And along with that, we ended up looking at some double angle formulas, compound angle formulas, and we derived the double angle formulas from the compound angle formulas. Okay, so that's the comprehensive thing. Main thing about trigonometry is you need to understand the unit circle. Okay, if you don't understand the unit circle, and if you just memorize and put something on the exam, then you might get a good mark, but that won't indicate you understanding it, right? And if you understand it, then things get a lot more easier, right? Okay. All right, then. Good luck with trigonometry, and see you later.